This is your lesson 35 systems of equations video. Go ahead and pause the video, annotate your learning targets, and I'd like for you to read through task 1, the speller review, and try to do all the way through number 16 if you can, and then I will help you with 17 since it's been a while since we've solved systems of equations. Okay, so as always, feel free to pause the video at any time if you need to write things down or modify one of your answers. So, of course, it gives us a review on what linear, quadratic, exponential, and absolute value are, not only what the equations should look like, but also what the graph of the function should look like. So feel free to double check your answers with mine. Number 13 through 16 is when you had to narrow it down a little bit more. So for example, number 13 was absolute value because of the V shape, but there were two absolute value options. And I noticed one was a +5 and one was a -2. And I noticed the V shape was shifted down 2 units. So I chose the one that had the -2 at the end for the y-intercept. 14, similar idea. I knew it was quadratic, so it had to have the x squared. And then I went with the -1 at the end since it appeared to be shifted down 1 unit. Number 15, same idea. I knew it was linear. It had been shifted up 3 units, so I went with the letter A. And then number 16 is exponential with that J shape, and it was shifted down 1 unit, so I went with letter D. All right, number 17, this is where we're reviewing how to solve by substitution. So remember, you're trying to find the point of intersection of these two functions if you were to graph them. So you can do that algebraically 2 different ways. Substitution or elimination, and of course you could graph as well, but here we're asked to solve by substitution. So I noticed that it says y equals x minus 13, so I'm going to take what y equals and I'm going to plug it in for y into this other equation here. So I have my other equation, 4x plus 2 times y equals 10, and notice I left a space to substitute this x minus 13 in. Since that is y, I can use it in place of the y. So I'm going to have to distribute. I'm going to go and bring down my 4x, and then 2 times x, 2 times -13. I have 6x. I'm going to go ahead and add my 26 to both sides. Divide by 6 gives me an x value of 6. So I'm going to go get my ordered pair up here ready for my final answer. My x value I know is 6. Now I'm ready to plug that back into one of my original equations to find my y. So I know that y equals x minus 13, and x was 6, so I can plug that in. And then that's just going to be a simple expression to simplify. 6 minus 13 would give me a -7. So my final answer is 6, -7. Of course, I could plug my x and my y back in for both of those just to confirm it's giving me true statements. And so I'm just doing that with a calculator. And I'm getting true for both, so I know that that is correct. All right, if you would like to go ahead and pause the video, try letter B, and then we will bring it back to compare answers. Okay, so I went ahead and solved by substitution just like I did in letter A, and I ended up with 3, -8, and I plugged those in, and they both give me true statements for the equations. So we are ready to go on down to the next task here, task 2. So it says that Professor Hurst is studying different types of bacteria in order to determine new ways to prevent their population overgrowth. Each bacterium in the first culture that she examines divides to produce another bacterium once each minute. In the second culture, she observes that the number of bacteria increases by 10 bacteria each second. If the second culture increased by 10 bacteria each second, at what rate did it increase each minute? Explain. So go ahead and pause the video, maybe reread number 18 to yourself again and see if you can come up with an educated guess on what's happening there. So if it's increasing by 10 bacteria each second, we know there are 60 seconds in a minute, so that would be 600, increasing by 600 bacteria each minute. All right, number 19, each population began with 10 bacteria. Complete the table for the population of each bacteria sample. So what I would like for you to do is go ahead and fill out the table, and I'm going to go ahead and help you fill out the independent time column real quick. So we're just going to keep it simple with 0, 1, 2, 3, and 4 minutes, and then go ahead and complete the table if you would, please. Okay, so population A doubled every minute. So I started out with 10, which is what we were told, and then I just doubled for each passing minute. Whereas on the second population, or sample B is what we're calling it, it also starts out with 10, but it increases by 10 bacteria each second, so we know that that's 600 each minute. So I just added 600 for each minute, and we could see how quickly that added up over here as the bacteria added. All right, we are ready to continue, so I'm going to ask that you pause the video and go ahead and try the next couple problems on your own, and then I will bring it back to compare answers. Okay, so looking at number 20, I noticed that the bacteria doubles each time for population A, so that is going to be exponential growth. And then for population B, there is constant change in the X and the Y, so I know that population B would be linear. 21, I went ahead and did write a function to model bacteria A, and so I started with 10 and it doubled each time, so my growth rate right here would be 2, or this is also known as a common ratio, would be 2 since it doubles, and then it's exponential, of course, so my independent variable t for time here is actually my exponent up here. All right, 22 says evaluate the function using 2 input-output pairs. So you're going to show that your function is accurate by pulling 2 of these ordered pairs for population A. So for example, if I were to plug in 0, my output should be 10. If I were to plug in 1, my output should be 20, so on and so on. So we have 5 pairs here. I'm asking you to choose 2 of them and do the input-output, evaluate that function to confirm that this equation would in fact represent my data correctly. So go ahead and pause the video, try number 22, and then if you can, go on with number 23 and 24. 23 is just asking you to write a function that's linear, so I think that we should be able to do that. Okay, so I evaluated using 2 and 4 for the exponential function right here, and then I confirmed that the output was the same as the table, so I knew that my expression, or excuse me, my equation was accurate. And then I wrote my equation for the linear function here. It started with 10 and then it increased 600 per minute, so 600 is my slope. It needs to go next to my independent variable t. And then I again chose 2 ordered pairs from the table to evaluate that to confirm my equation was correct. So I chose 2 and 4 again, and I confirmed that those were correct. So looking at number 25, we're going to ask you to use a graphing calculator. So at this point, we're going to ask for you to access Desmos Graphing. So if you just go to desmos.com, you can hit Start Graphing, and then you can use that to answer question 25. And I would like for you to go ahead and try 26 and 27, please. Okay, so here you can see my sketch, and then I made sure to label my axes and label which function was represented by which population here on my graph as well, so I could visually see that. Letter D, I did determine the intersection points of the 2 bacteria, and here's my Desmos graph to better show that as well. And then 26, explain what the intersection points of the functions represent within the context of the problem. You could have worded this slightly different, so feel free to add to your answer if you need to, but just because you don't have the exact same thing doesn't mean that it's necessarily incorrect. I said the 2 intersection points represent at which times, after t number of minutes, the 2 bacteria populations have the same number of bacteria. Number 27 says fully explain which bacteria population contains more. I said both populations started with the same number of bacteria, 10. From then until around 9 seconds, population B had more bacteria. After about 9 seconds, population A's number of bacteria surpassed population B's and remained more. Because you can see that, you know, after they intersect, this exponential growth surpasses population B and will continue to remain with more bacteria because of that exponential growth compared to the linear growth. Go ahead and read through task 3 and try to use your Desmos graphing calculator to graph number 28. It specifically asks you to use your graphing calculator so you can fill out the table and then use your Desmos graphing calculator to graph those. Okay, so I chose to fill out my tables just with some basic 0 through 4 points. Of course, I could have chose some negative numbers as well, but I just kept it kind of simple since I'm going to use the Desmos grapher anyways to kind of help me along. So feel free to pause the video and compare answers there if you would like, and let me show you what my graphs look like as well. Okay, so here are each of my graphs for A, B, and C. So pause the video if you want to kind of pull some of those points from there if you need to. Of course, if you already graphed them, you can probably just kind of visually see if they're similar or not. Okay, we are ready for task 4, it looks like. We're going to solve each system using algebra, so we can use substitution or elimination, and then we're going to use our Desmos grapher to check it. Notice this is very similar procedure as before, except for now, instead of just linear functions, we have some quadratic functions in here, but we're going to use that substitution the same. So if I'm going to substitute for y, I know that this right here is equal to y, so I can take it and I can plug it in for y into the other equation. So basically what I end up doing is setting these equal to each other, these expressions. And then I'm going to get 0 on one side so I can use my quadratic formula to solve. So I'm going to add this x on both sides, which will cancel both of those. And I'm going to subtract the 2, which would also, coincidentally enough, cancel that. And that just leaves me with x squared equals 0. So I need to solve this quadratic. Oops. And if you're looking for x-intercepts as your solutions, there we go. If you're looking for x-intercepts as your solution, you probably realize that this is our parent graph. This is our parent function. So, of course, we can do our quadratic formula, but you might already know in your head what the x-intercept or intercepts of this quadratic function is, because I would have negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's going to be negative 0 plus or minus. This in here is going to end up being 0, and the square root of 0 is 0 all over 2. So 0 plus 0 divided by 2, 0 minus 0 divided by 2, either way is just going to give me one x-intercept, one solution of 0. And then, of course, I could graph that, just the x squared with my Desmos grapher. Get rid of those for a minute. X squared. There we go. And now I can see, obviously, that my only x-intercept is at 0, 0, because this is the parent graph. Okay, so back here, if x is 0, I have to plug that in to one of my original problems to calculate what my y value is. So if I am plugging in x is 0 for this original problem here, I have y equals, there is no such thing as a negative 0, so I can just leave it at that, and I got y equals 2. So as an ordered pair, I'm looking at 0, 2 as my answer. And at this point, go ahead and pause the video, try the other two problems, and we'll bring it back to compare. Okay, quick comparison here. Here's my answer for letter B. Feel free to pause the video and look at that further. Letter C is going to be on this attached paper. You're probably going to have to pause the video to compare.